Good morning, Year 9s. Today is the 5th of April, 2020. We're now moving on to a new chapter, which is Sets Part 1. And in today's lesson, we're going to do questions 1 to 5, which is on page 95 of your book. So the title for today is Sets 1, Part 1, questions 1 to 5. And the learning intention is to be able to use set notation. And then later on, we'll have a look at using Venn diagrams to represent sets. So if we move to the next page. So it's in your book. I'll just quickly go through it. So the set, or the ideal set, is simple but powerful. So it wasn't originally created by Cantor, which was a German mathematician. It was a previous British mathematician, which I forgot his name, but I'll find that out and I'll get back to you guys. But it just shows, you know, how it's been used, and it's used now, especially in statistics with probabilities and finding highest common factors and those common multiples and plenty of other work. So the basic principles regarding sets is to recognize different types of numbers. So you've got odd, even, prime numbers, square numbers, know the properties of triangles and quadrilaterals, and understand multiples and factors of numbers. So sets and Venn diagrams. Now I'm going to switch over to the PowerPoint, which will also upload, so you can look at it separately if you need to. I'm going to hopefully share this with you guys. So if I go back to it, a new share, which is here. So starting it now. So sets, well, as you can see, a set is a well-defined group of objects such as those shown below. And the set can be finite or infinite. And this is one of the issues Cantor had when he actually proved that sets can be of different sizes. So the members of a set are called elements, which is written as E. And if an element E belongs to a set S, then in set notation, we write it as E is an element in this way, with Greek letter here, of S. E is an element of S. So for example, if we look at this first one, set A, which contains elements London, Rome, Paris, Cairo. So this is basically a set containing European capitals. Look at set B, it's got these numbers 3, 7, 9, 14. These are the elements. And we can describe this as a set of odd numbers. Here, set C contains the elements. And one other thing I should also mention before I forget, when we're writing sets, you need to use these curly brackets, not the brackets that we normally use, but you need to write them in curly brackets like here, shown here. If you write them in any other way, they will not be recognized as sets. You need to make sure the notation with where you write sets is done correctly. So moving back, so here set C, it has these elements, which is basically the letters of the alphabet. Here D are the square numbers 1, 4, 9, 16, 25, 36. And as we said before, some sets are finite, even that there's only so many things that will elements will be in that set, and some sets are infinite, they will go into infinity. So in this example here, we can say Rome is an element of set A, 7 is an element of B, Q is an element of C, and then is final example here, D is an element of, 100. If I further go down, 100, which is 10 squared, which is an element of D containing the square numbers. So if an element E does not belong to set S, then we write this as, again, the same Greek letter here for this, epsilon, I think it's called, with a line drawn across it to show that it is not an element. So this is read as E is not an element of S. So example, here is written as Munich is not an element of A. Now Europe is, obviously Munich is a European city, it's in Germany, but it's not the capital of Germany. So remember, it's European capitals. I'm not sure why Cairo is mentioned in there, because Cairo is a capital of Egypt. So maybe there's a mistake in that set there. Here again, here we say 20 is not an element of set B because it is not an odd number. Here we could say the letter beta or beta is not an element of C because beta is a Greek letter, not the letter of the the Latin English alphabet that we normally use. And here again, 63 is not an element of D. 63 is not a square number, so it does not belong in this set. So in this part, the question is describing words as sets below and state whether they are finite or infinite. Where possible, use set notation to write down one additional element as a member of a set and one that isn't. So if you was to look at set A, how would you describe a set? I'll let you think about that and write it down. And also, do you think this is a finite set or an infinite set? Here you've got B. What do you think this set is? What are these elements? Here you've got C. What do you think this would set be representative of? And D, E, F, and G. Again, we'll come back to these later on. I'm not going to show you the answers now. I just want to have a think about it. So we'll go back to the questions in our book. So yes, moving on. So we've got exercise 1, and it says write down 2 more members of these sets. So here you've got carrot, potato, pea. So what do you think can be in here? So obviously these are vegetables that we eat. So think of 2 other vegetables that you think might join in this set. Here you got the colors red, green, blue. So it could be just looking at adding 2 more colors. Here we've got A, B, C, D. So what do you think would be another 2 members that would belong in this set? And here we've got D, 1, 3, 5, 7. So think about what are these elements of this set. And again, notice how the brackets are curly brackets, not your smooth brackets. And then here it says question 2, list the members of these sets. So here you've got the days of the week. So what would be in that set? So obviously you need to write down Sunday, Monday, Tuesday, Wednesday, and so forth. Square numbers less than 101. So again, if you look at the examples in the PowerPoint, that showed you what was the first 5 square numbers. So remember, square numbers are the numbers multiplied by themselves. Here, subjects you study at school. So again, you can write down the subjects you take at school, like English, maths, science, DT, ICT, Arabic studies, Spanish, geography, all those kind of things. And then write down lists of prime numbers less than 22. So again, you might need to look it up on the internet or look at the back of a book where the solutions are to write the prime numbers less than 22. On the next page, it says for question 3, describe this following sets by rule. So again, what do you think would be for this, elements of this set? So we've got A, B, C, D. So this could be this set containing the first 4 letters of the English alphabet. Here for part B, it writes Tuesday and Thursday. So this could be described as the 2 letters of the 2 words, or 2 days, sorry, of the week that begin with the letter T. So you guys now have a look at doing the rest of the questions, C and D. Question 4, which of these statements are true? So cat is an element of animals with 2 legs. Is that true or false? A square is not an element of parallelograms. True or false? 1 is an element of the prime numbers. True or false? Again, you can, these are all, something you can quickly work through yourselves. Question 5, which of these are examples of an empty set? So, for example, the set of men with no teeth. So would you have ever set of men with no teeth? That'd be an empty set, or would it actually have a few elements in there? Part B, the sets of the months of the year with 32 days. So that one again, if you think about it, it's actually empty set, isn't it? Because there's no days of a month with 32 days. Again, I will let you do the rest of the questions, part C and D. So that's for today. Tomorrow tomorrow's lesson, 6th of April, we will continue with sets part 2 using set notation, and we will look at questions 3 to 5. So we'll stop there for now. Any questions, please message me, or you can message me on Google Classroom or email me, and I'll write back to you. Or alternatively, you can ask me to, and we'll set up a quick one-to-one Zoom session so I can talk you through things that you need support. Anyway, enjoy the rest of your day, and I look forward to seeing you guys tomorrow.